Okay, so we have another method. We have the shell method. The shell method is used in pictures like this, where we have just a difference. Does that make sense? Mm-hmm. We have this difference here. Use the shell method because it uses cylinder shells. You can use it here in this type of shape. We're revolving it around again, X and Y axis. So our shell method is for horizontal. Axis revolution. So that would be a picture. I don't even know, but so if I'm revolving this shape, and so I need to get this piece around the x-axis, or I could be a line up here also. It doesn't have to be the x-axis. Your equation is v equals 2 pi. Again, we have a circle, right? Mm-hmm. A to b of p of y times h of y dy. And so what that means is, let me come here. So from here to here, this right here is your h of y. And this is I should have made my box better. I'm going to do this. This H, I'm going to make my picture bigger so you can see actually what's going on. Sorry. I'm going to make sure you understand where those both, because this is a perfect rectangle. So H comes to the edge on the outside of the shape. Do you see that? Mm-hmm. And then P is where it intersects. It intersects to the axis of revolution.
So that whole gap?
Mm-hmm. Now, sometimes that intersection is in the middle of that rectangle, but H is the horizontal. That's why I always remember H is my horizontal. But on the next one, it's not. So, yeah. So H is from the beginning of the shape to the corner. And this is where it intersects your shape. So then vertical, axis of revolution. I forgot my of on the other one, didn't I? Is volume equals 2 pi again, because we are dealing with the circular object. The integral from a to b of p of x times h of x. Now, dx. You might be thinking, well, p and h can be mixed around, right? Just change it. So when I have my picture and I'm revolving it around my vertical axis now. So I have my same picture, or close to it. I have my rectangle that is up and down. Oops. Made that way too wide. So my H is still from the outside corner, but to the bottom of the shape. So if you look at it, and it's X because we're measuring it, it's measured on the X-axis, we're doing that. But if you look at it, where this H up here is from the edge to the corner, and this one is from the edge to the corner also. See that? Now this one, from here to here,
Halfway.
yeah, about, is your P of X. And obviously A to B is on the X-axis here. But over here we're measuring it on the what?
On the Y.
On the Y. And they use different letters, but I still use A to B. They use like C to D. But it's still just a difference on there. Okay, so those are your equations. That's about all I can tell you. So we have find the volume of the solid of a revolution formed by revolving the region bound by y equals x minus x cubed, and the x-axis zero is less than equal to 1 about the y-axis. Okay, so which one of these revolves around the y-axis? The horizontal or the vertical?
The one with the Y's.
Yeah.
Horizontal.
No, the vertical.
No, the vertical.
Okay, the vertical. It's the x-axis is vertical. So it's a vertical. Like the x-axis is a vertical line, yes?
Yes.
And it's kind of confusing because you go x-axis, but I want the x's. Y-axis, I want the x's, x-axis, I want the
Y's.
y's. Okay, can I move it up?
Uh-huh.
Okay, so my range is from 0 to 1, right? Tells me right here.
Yes.
Okay, so V equals, it might be good to graph this, huh? Yeah,
Maybe.
probably. So I'm going to want a graph from 0 to 1, and I can throw it in my calculator if I want. So I have x minus x cubed. So we obviously know we're pointing down at some point in this, right? And we want 0 to 1. So I'm going to go to my window, and I'm going to put like negative a half on my x to only 1.5. Because that's all I need to see. I don't need to see anything else, do I? I don't know how far it goes up on my y yet. So I have negative 2 to 10. That's fine with me. So there's 0. And there's 1. So that's pretty little, isn't it?
Mm-hmm.
Okay, but that's, so I can make it just look, it probably goes up to a half or so. So we know that it looks like, it's not symmetrical, is it?
No.
I have a hard time making it closer to the x-axis near the 0. My brain doesn't want to do it. Kind of something like that. This is 0, this is 1, just to have an idea, right? And they even zoomed. Look, they even zoomed in. They made it a closer. They just made the shape. That's all we need, just to give our brain an idea. So remember, we have a rectangle, right?
Right.
So from here...
You could just put the rectangle wherever you want.
Yeah, because it's going to move. That's why it's the integral, because it steps through it. And from here down is my h. So the two equations we dealt with are the x-axis. What equation is the x-axis? What kind of line is the x-axis?
The horizontal line.
Horizontal. So the equation is actually y equals 0, isn't it?
Yes.
Okay. So
Wait, why is it y equals 0?
because because it says this equation y equals x minus x cubed and the x-axis. So if I were going to draw a line on the x-axis, that x-axis would be y equals 0, wouldn't it?
Mm-hmm.
Okay. So their sum is x, and why are they doing this x? Because I have not done this in forever today. And my brain is done. Okay, so for the distance from the center of the rectangle to the axis of revolution is x. So this to here is x. It's some arbitrary x as that rectangle changes, correct?
Yeah.
Okay, so my p of x is x. So my equation for this is 2 pi, the integral from what to what?
0 to 1.
0 to 1, of p of x, which is x, times h of x. Well, h of x is going to be this height of that rectangle is going to be determined by y equals x minus x cubed, isn't it?
Yes.
Okay, so x minus x cubed. So again, let me go over what it means. We're taking the distance from the beginning to the middle of that rectangle, wherever it is, we're just as x. It's just some amount.
Okay.
And that height of that rectangle is determined by the actual function. So we have x times, so that would give us, we want to multiply that out, don't we? So the integral from 0 to 1 of x squared minus x to the 4th dx. So hopefully you guys could do this integral fairly quickly. 1/3 x cubed minus 1/5 x to the 4th. Unless I did that incorrectly. 0 to...
You mean x to the 5th?
Yes. I did my 1/5. I did the hard part. If there is a hard part on that one. And then I just do from 0 to 1. So if I plug in 1, and remember to leave that 2 pi out. Don't put it in there till you're done. If I put in 1, I get what, 1/3?
Minus 1/5.
1 minus 1/5.
Yeah.
And then minus, if I put in 0, I just get 0. So 1/3 and 1/5 is 15. So I get 2 pi times 5 minus 3 over 15.
Should be 2 over 15.
So 2 over 15, so 4 pi over 15.
Yeah. 4 pi over 15?
Mm-hmm. Because we have the 2 pi out here. And then 5 minus 2 is... 5 minus 3 is 2. 2 times 2 is 4.
Oh, you actually...
Mm-hmm. So it's not, the worst part about it is really kind of making sure you have the right, like, I think the worst part about it is you're like this. Like, knowing where to put the equations, I guess. Which ones?
Want me to use which one not to use?
Yeah.
Did you notice that she was getting a sub-license? He signed the paperwork today.
So we find the volume of a solid revolution formed by revolving the graph of x equals e to the negative 2 squared, or negative y squared, negative 2 squared. And the y-axis. Zero is less than equal to y, which is less than equal to 1, about the x-axis. That is a horrible E. So we did the horizontal, now we're going to do the vertical. So our picture and we only want from 0 to 1, right? Wherever your 1 is at. You cannot graph it on our calculators. You can use Desmos. Because this is an x equals, well, I guess you could put natural log of both sides, right? So we have the natural log of x equals negative y squared multiplied by negatives. So you have negative natural log of x and the square root. That's interesting. Desmos would do it just like this. Okay, so square root of negative natural log. I don't know if it will do it. No, we can't have the can't take a square root. We cannot take a negative square root. Can we?
No.
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 It's going to scream at me and say, dummy, you can't do it. Oh, evidently I can. Okay. So I only need from 0 to 1 on the y-axis, don't I?
Yeah.
So that's way too zoomed out, isn't it?
You need to zoom.
So I need to zoom it in some more. So I only need, on the y-axis, I don't need 10. So I only need 1.5, and I need 0.5. I mean, negative 0.5. And I don't even think I thought we had plenty of y-axis, don't you? I mean, x-axis. Okay, so our picture, it's not even going to be closed up here, is it?
No.
No, it's going to look like this.
Yeah.
That's pretty good. So I want this. Now, do you see, since it's not closed, do you see how there's this open? If I revolve this shape, is there going to be an open area in the middle? Because it's not closed, is it? It's going to have open. So I need this, and my rectangle just looks like this. So this equation was brought to me by my shape, wasn't it? So this, my h of x for my picture, is going to be the x equals. H of y, not h of x. They should have yelled at me. And then my p of y is going to be, and that's just going to change by y, isn't it? Whatever y value I plug in there. So this equation was, what was it? It was p of y times h of y. Now, since it is multiplication, does it matter which one you multiply by which?
No.
No. Does it matter that you know one's y and one's the equation?
No.
Yeah. Well,
Yeah.
yeah. Okay. So we have volume equals 2 pi. Integral from what to what?
0 to 1.
0 to 1. Of, you want to do y? I always like to do my single one first. Times e to the negative 2y squared
Yep.
dy. So now I get to integrate that. So that's just y times e to the negative 2y. So you might want to get out your integral rules. What's the integral of e to the u?
Oh,
It's just regular EU plus C.
Plus what? Plus c? So our integral of e to the negative y squared should be 1/2 though, shouldn't it? I don't think that's quite right.
Because it says EU.
E to the u
Do you have to find the
du equals what?
EU plus C? Like the integral of EU du equals EU plus C.
What other exponent one? What other e do you have? Nothing?
I have the integral of e to the x dx equals e to the x plus c.
Oh yeah, it's the same one.
Mm.
This isn't like e to the u du isn't like u prime times e to the u.
No. That's our. I have that for derivatives. Well, maybe I just didn't write it down because I had it in my derivatives.
I
But
think
for-
we have to do this one by parts. Because we have this.
No, I know. I'm saying that.
Yeah.
I probably didn't write the integral rule down because I had it in derivative.
So u would be y squared, correct? So du would be the derivative of this,
Which would be negative 2y.
which would be negative 2y.
Okay.
Yes?
Mm-hmm.
Oh, okay. Okay. Duh, my brain is like going nuts, guys. Okay. So we're here.
Mm-hmm.
What are we missing? Because we would have this. We should have negative 2y e to the negative y squared. Yes?
Yeah.
That's what we should have if we did the derivative of it. What are we missing?
Missing
A negative and the 2, right?
Yeah.
So there would be a negative 1/2.
Mhm.
Okay. My brain was just like gone. It's gone. So it would be negative 1/2,
Yeah.
and then the integral would be e to the negative y squared from 0 to 1.
Yeah.
Well, the negative 1/2 is a constant, correct?
Yes.
Which I can pull out. So that just gives me negative pi.
Mm-hmm.
And I have e to the negative y squared from 0 to 1. So if I plug in 1, I get e to the negative 1. If I plug in 0, I get
E to the 0.
e to the 0, which is 1,
Yes.
which can't leave the negative exponent, right?
Yeah. So then it'd be E over.
So pi, negative pi times 1 over e minus 1. Or I could throw the negative into it. They did. They wrote it as pi 1 minus 1 over e. Because they didn't want the negative on the outside. I probably would just leave it there. Now, biggest problem here is remembering our integrals, right?
Yeah.
So your assignment is on Classroom.